Hello, hello, hello. So good afternoon, everyone. I am Devarun Banerjee. I am Devarun Banerjee. I'm going to share. I'm sharing my screen as beginning this live interaction session number 6 for this NPTEL course of Technologies for Clean and Renewable Energy Production. And I'm a PMRF scholar from Indian Institute of Technology, Delhi. So every class, what we do is we try to get an overview of whatever has been taught in this entire week. So the first lecture in this week, this few things about the solar energy has been taught. So among them, the sun as a source of energy, solar radiation and spectrum, solar insolation, some facts, application of solar energy, advantage and disadvantage of solar energy, techniques for solar energy conversion to usable form, uh, and among them, what are the techniques like solar thermal, solar photovoltaics, these kind of techniques have been discussed. Okay? If you see the slides, mm, so in general, the major energy source of our ecosystem is sun. So among the components of the ecosystem, the biotic component, abiotic component, and energy, these are the important things. Majorly, uh, for the energy perspective, sun is actually very important because this is what all the recipient of the radiant energy from sun, and then uh, by using this kind of radiant energy, the organic materials are synthesized from the inorganics by the different production methods, and then these producers, which mean the vegetations, are actually consumed by the consumers, and then after the death of this kind of producers and consumers, different complex organic components are degraded. So overall, there are about autotrophs, which is about the maximum amount of solar energy recipient. After that, the herbivores is about 630 units of production, and then the carnivores, it takes about 125. So overall, only 0.2% solar energy is consumed through photosynthesis and stored as chemical energy. Rest remains unused. The part of the solar energy, unused solar energy, can be converted to its usable form if the proper technology is developed. So the energy radiated out from the sun and received by the sun, earth, is called the solar energy, and this is the overall thing which has been taught in this class. Okay. So overall, the solar radiation and spectrum, so such as the energy from the sun reaches earth's surface in the form of solar radiation. Okay. So what is the form of this particular, and what is the detail of the solar radiation? The maximum intensity of solar radiation, known as solar constant, which is defined as the total energy received from the sun per unit time on a surface of per unit area. Okay. So this is the solar constant, which actually can be used to quantify the solar energy availability. The overall value of the solar constant is about 1366 watt per meter square. Overall, the solar spectrum, it tells you about with the increase of the wavelength, okay, how these things can get shifted from the UV zone to the IR zone, and we get the gamma rays at a very low wavelength with a high intensity. The X-rays being in wavelength between 0.01 to 10 nanometer, ultraviolet rays, UV rays between 10 to 1000 nanometer, and then the IR rays and the radio waves. So the major portion which is available, which is the visible light, is about less than 400 to about 800 nanometer. See, but it is a very narrow region. Only about 4% of the entire solar spectrum. This is the visible light which are available. Okay, these are the further variables which have also been taught, and the different applications of solar energy includes water heating, uh, air heating components for agricultural and industrial applications, building heating and cooling, cold storage for preservation of food, cooking of food, greenhouses, distillation of water, water pumping, like this. Okay, so these are the major applications of solar energy, and it can be used to for the heating and cooling of buildings. Okay, so in the winter time, you can use the heating of the buildings, and in the summer time, by a variation of the design, it can get a, you know, the solar radiation would be prevented to enter the building. So this kind of things, the design of building is important, and you can see this written also here. The proper design of a building is for it to act as a solar collector and storage unit. This is achieved through three elements: insulation, collection, and storage. Passive solar design is a set of practices that accommodate the local climate by letting the sun into the building in the winter and keeping the sun out in the summer, which I have been telling earlier. Okay, and the overall design, involves different portions such as the collection of the solar energy, insulation on the external walls, roofs, and the floors. The doors, windows, and vents must be designed to minimize the heat loss. Storage of this solar energy in the form of thermal. So it can be stored in different storing mediums such as water, iron, wood, brick, concrete, bluestone. Overall, a passively heated home uses about 65 to 30, 60 to 75% of solar energy that heats its walls and windows. The Center for Renewable Resources USA estimates that in almost any climate, a well-designed passive solar home can reduce energy bills by 75% with an added 5 to 10% construction cost. Okay, the loss of energy, the 25% of energy, it used for water and space heating. In general, and overall advantages and disadvantages of this kind of systems are, you can see here. The advantages include all chemical and radioactive polluting byproducts of the thermonuclear reactions remain behind on the sun, while while only pure radiant energy reaches the earth. Okay, and
वो वाला वो जो ऑटो क्लेव ठंडा होने के बाद ही खुलता है क्या? उससे पहले नहीं खुल सकते? ऊपर का नट तो खुल जाएगा, मुड़ नहीं रहा।
अभी नहीं खुल रहा, ठंडा होने के बाद ही खुल। So utilization of this solar energy is about utilizing its renewability. So overall the 30 days, and it can see that 30 days of sunshine striking the earth have the energy equivalent of the total of all the plant's fossil fuels. So it is very important to uh, efficiently utilize whatever solar energy we are getting. Okay, that is the most important thing. However, the inconsistency of the sun shining is one of the disadvantage, and overall the diffusion, the sun rays where it falls, it's the overall a diffuse source. So therefore this kind of the collection and the concentration of the sun into a particular form is very important. Okay, coming to the second lecture. The second lecture, what has been taught here is uh, again the continuation of the solar energy, the sun as a source of energy, solar radiation and spectra, solar insolation, uh, application of solar energy, advantage, disadvantages. Up to this we have seen. The other portion has been taught in the second lecture is techniques for solar energy conversion to usable form. Among the techniques, solar thermal and solar photovoltaics are there. Among them, the solar energy, you can see it can be converted to usable form in three different ways: by solar energy to thermal energy, solar energy to electricity, solar energy to chemical energy. Okay, so via either via thermal conversion, via photovoltaic approach, via photosynthesis. This kind of approaches are utilized. Okay. So among them, there's different solar thermal energies, solar thermal collectors, the different types of collector. These are concentrating collector, flat plate collectors, evacuated tube solar thermal collectors. All these are discussed. Concentrating solar thermal collector. Uh, these things are all discussed. Okay, and based on that, solar thermal power plant can also be designed. And kind of an example of power tower in Barstow, California. It has been shown here, and an example is the 10 megawatt solar power plant in the California, where 1900 heliostats, a central 295 feet tower. These can be seen. Overall, the obviously the operating cost and this efficiency would be a differentiator, and there is an initial case. It can be said that the capital cost is actually greater than the coal-fired power plant. The other form of solar energy conversion is through solar photovoltaics. The different construction materials and this efficiency calculation have been shown in this particular lecture. How the IV curve, the current voltage dependency is there. This is also discussed, and the PV cell details have also been discussed. Among them, the PV module, how these things sizes are there, single crystal, polycrystalline material, uh, how the variation of energy efficiency is there, the different hierarchies of PV cells, like the minimum thing is the cell, which gives an energy about 2-3 watt. Then is a module, which is a combination of different multiple cells. About this one C is a combination of 54 cells. So 9 rows and 6 columns. So 6 into 9, 54 cells are there. About 100 to 200 watt energy can be generated here, and then further to the kilowatt level is about 100 to 300 modules are there with these 54 cells each. So about 10 to 50 kilowatt of energy can be unleashed. So this kind of hierarchy is also shown of the PV cells, and overall roughly estimation of the size power station is that 1 kilowatt PV equals to 10 meters square. So it means that if we have a 20 by 10 room, then we can install a 20 kilowatt power photovoltaic in this particular room. Okay. Third lecture was all about the wind energy. So wind as a source of energy, uh, wind energy system, types of the wind machines, energy production from wind, wind energy computation, nature of wind and selection of site. These are actually discussed. Yeah. Overall, wind is simply air in motion. You see that it is caused by the uneven heating on the of the Earth's surface by the sun, because the Earth's surface is made of very different types of land and water. It absorbs the sun's heat at different rates, and such as one of the such example, it can see that it can be found, this kind of example can be found in the daily wind cycle. Mm. Wind energy, what is actually wind energy? It is uh, nothing but the kinetic energy associated with the movement of atmospheric air, and it has been used Okay, so the wind energy systems convert this kind of kinetic energy to more useful forms of power. So overall, the wind energy is now the second fastest growing source of electricity in the world, with a global installed capacity of about 539,581 megawatts at the end of 2017. You can see this is a pretty old data. More and more, this wind energy is actually increasing with day by day. Overall, the top 10 wind energy production countries as on December 2017 has been shown, where People's Republic of China leading by a good margin. So the components with having a wind energy system, wind machine, which converts the wind energy into the useful form of energy, windmill, which works on the principle of kinetic energy conversion of the wind to the mechanical energy, wind turbines, which transforms the energy in the wind into mechanical power. Then it can be used directly for the conversion to the electric power. So this is the overall system. So this is very important thing. The wind speed typically increases with the height above ground. Okay. So due to what is the reason? The friction with the ground is gradually decreases. That is why wind turbines are mounted on a tower to capture more energy. At 100 feet or more above ground, they can take advantage of faster and less turbulent wind. For the best utilization of wind turbines, they should be placed where wind speeds reach 16 to 20 miles per hour and at a height of at least 50 meters. So their axis of rotation, it can be on via a horizontal axis or a vertical axis. So the horizontal axis machines have the axis of rotation is parallel to the direction of the wind stream. On the other hand, the vertical axis is the example of the vertical axis machine, where the rotational axis is actually vertical and it's fixed. Okay, so this is the advantage of the horizontal machine. It can be adjusted uh, so that it's parallel to the direction of the wind stream. So if you want to see the comparison between horizontal and vertical axis type wind turbines, you can see that horizontal axis wind turbines, it having a controller, it is required for proper orientation. On the other hand, vertical axis, no controller is required. It is actually a lightweight thing, horizontal axis wind turbine. However, the vertical one is too bulky, having much more material. Uh, Important thing is that the variable blade pitch can tolerate wider fluctuation in wind speed. So it might be this kind of wind speed variation uh, due to turbulence or something. Uh, it can tolerate. And on the other hand, the vertical axis, the machine performs even at lower wind velocity. So from 8 to where there is a lower wind velocity, can utilize the vertical axis wind turbine, or the where there is a higher wind speed with maybe a bit of fluctuations also, it can use the horizontal axis wind turbine. The power production from wind is very important. The kinetic energy, this kind of different formulas are given here. We have to read these things. Okay. Then different factors like tip speed ratio, like wind shear, the wind speed power equation, where this you can see that with how much velocity and the height we are having, this kind of the velocity can be uh, you know can be determined like with the increase of the height. So general rule of thumb is that the wind speed increases as the 1/7 power of the height above the ground. It- Moreover, the this alpha actually varies. This alpha is more or less 1/7 is a general rule of thumb, but it could be varying with the region. Like smooth hard ground, lake or ocean having a alpha zero point 0.1. Short grass on untilled soil is about 0.14. Level country with foot high grass 0.16, like that. Further wind energy computation are shown here, and overall the nature of wind and selection of site will be very important. So the factors which affect the nature of the wind close to the surface of the earth are the latitude of the place, the altitude of the place, the topography of the place, scale of the hour, month, and year. So this is the overall uh, wind turbines activities, and other lecture have been shown the parts of windmills. As already told, the horizontal axis, vertical axis windmills, the rotors of windmills, advantage and disadvantage of windmill, wind energy in India, and overall the future of windmill. Well, if we have time, we'll get back to this. Otherwise, go for the question. Okay. So the sample assignment questions we discuss in this session. So the first question is, which of the following factor influences solar insolation? Daily variation and atmospheric clarity, area of surface, angle of incidence, or all of the above. So the correct answer is all of the above. The solar insolation is nothing but overall the solar radiation which is received on a flat horizontal surface at a particular location on Earth at a particular instant of time. Okay, this is the solar insolation. So what amount of intensity of solar energy is we're getting in a particular area per watt per meter square. So it depends on various factors such as angle of incidence, daily variation, seasonal variation, and geographical location of the particular surface, atmospheric clarity, shadows of trees, tall structures, adjacent solar panels, degree of latitude for this location, area of surface in meter square. So overall, the solar insolation is not available equally everywhere. We cannot say that each and every uh, location is will be getting a same solar insolation. It will depend on multiple factors. So all of the above is the correct answer. Next question is, select the most suitable option from the below. The angle of incident depends on the angle of declination, the direction of sun rays, azimuthal angle, all of the above. So the correct answer is again all of the above, because what is the angle of incidence? Means that the incident angle basically of the solar rays. So the is angle between the incident beam, which is denoted as the IBN, and the normal to the surface. Okay, so if we draw a normal to the surface S, uh, and we get a uh, incident beam ray, so there is an angle between this particular two space which is called as theta. You can see this is the ray and this is the normal. Okay, so and the angle between these two particular planes is called the angle of incidence. Okay, so what is this? The angle of incidence theta, it depends on several variables such as angle of declination, tilt angle, hour angle, latitude, azimuthal angle, like that. Okay, so it means that the uh, all of the above would be the correct answer. Okay. The next question is the angle associated with the location and orientation of the surface is known as angle of declination, tilt angle, azimuthal angle, or none of the above. So the correct answer is the azimuth angle. You can see that it is overall the compass direction from which the sunlight is coming at solar noon. The sun is always directly south in the northern hemisphere. So there is a different uh, location and orientation of surface. With the day, the azimuth angles gets changed. So you can see when the sun is here, this is the azimuth angle. When there is at noon, solar noon, this is no azimuth angle. The azimuth angle is 0. At the sunrise, basically the azimuth angle is 90 degrees. And again at the I think at the sunset, there is a minus 90 degrees. Okay, or the we can say the 270 degrees. Okay. The azimuth angle actually varies throughout the day. At the equinoxes, sun rises directly east and sets directly west, regardless of the latitude. Okay, so the azimuth angle is 90 degree at sunrise and 270 degree at sunset. Okay, so overall, in general, the azimuth angle varies with the latitude and the time of the year. So and also obviously when there is a this is for the absolutely the equinox. So depending on the location and orientation of surface, azimuth angle will get changed. and also throughout the day. The azimuth angle is the correct answer. The value of slope angle beta for the vertical surface is 0 degree, 180 degree, 60 degree, 90 degree. So the correct answer is 90 degree. So what is the tilt angle or the slope angle? Is basically the angle between the collector surface plane and the horizontal plane. Okay. So what happens is that I can see this is a basically angle which is called as a slope angle or the tilt angle. So for a particular vertical surface, obviously this angle would be 90 degree. For an entirely horizontal surface, this will be 0 degree. So it will be varying between these positive values. So beta is always positive. So for a vertical surface, this kind of line would be there. So with the mm, this particular beta would be the 90 degree. The most important features of the passive solar design are building and window orientation, insulation and building material, shading, or all of the above. So the correct answer is the all of the above. Uh, so the passive solar design is a set of practices that accommodate. कार्ड होगा कार्ड ले जाओ पैसा भर लेना. The passive solar design is a set of practices that accommodate the local climate by letting the sun into the building in the winter as already told and keeping the sun out in the summer. So the most important features is the building and window orientation, insulation and building materials, shading. These are all the most important features of the passive solar design. So all of the above is the correct answer. The most suitable option select from the options given below. The type of commercial, the type of commercial concentrating solar concentrating collectors are power tower, stationary concentrating collectors, parabolic dish, or all of the above. The correct answer is again all of the above. So the basic types of commercial solar concentrating collectors are parabolic trough system, parabolic dish, power tower, stationary concentrating collector. So these are the examples of this kind of different commercial concentrator collectors as shown here. This kind of parabolic dish is kind of this, where there is a receiver and there is a concentrated reflective surface. So it the sun rays falls over this particular concentrated reflective surface, and then the reflection happens and it goes to the receiver. Similar thing in the parabolic trough, uh, where there is a receiver. The difference in the receiver is there. You can see between the parabolic dish and the parabolic trough, and the power tower is having a tower kind of thing. It's coming in a combination of heliostats, so which can be moved according to the sun's location, and it goes to the tower. Above the tower, there is a receiver. Yeah. So all of the above is the correct answer. The collector efficiency of solar thermal collector expressed as there is a different kind of formulas given as options. The useful energy gain divided by solar radiation incident on collector, solar radiation incident on collector divided by useful energy gain, solar radiation incident on collector divided by solar insolation, or none of the above. So the correct answer is the useful energy gain divided by solar radiation incident on the collector. You can see the performance of the flat plate solar collector can be expressed by this kind of formula. Collector efficiency eta equals to useful energy gain divided by solar radiation incident on collector. Okay, how much energy gain is there is determined as the QU, and is divided by the solar radiation incident is expressed as the collector area multiplied by incident solar radiation, AC multiplied IT. Okay, so this ratio would be the correct answer. How much energy radiation is incident is getting on the collector, and among that how much is actually useful. So that ratio is the uh, answer for the collector efficiency determination. The next question is the typical values of the tip speed ratio. It ranges from different ranges are given as options from 1 to 15, from 5 to 15, 10 to 15, or 0 to 15. So the if correct answer will be the 1 to 15. So the tip speed ratio is basically a ratio of the blade tip speed divided by wind speed. So the efficiency of a wind generator depends upon the design of a wind rotor and the rotation speed expressed as the ratio of blade's tip speed to wind speed. Okay, so this ratio, the tip speed ratio, the TSR, it ranges between 1 to 15 typical values. So the higher tip speed ratio, it means that will be used, the higher tip speed ratio will be used instead of the rotor RPM, the term to help compare different rotor. Okay, so the higher RPM, it means that nothing but a higher tip speed ratio. It means that the blade tip is moving faster. Typical values of this tip speed ratio ranges between 1 to 15. Okay, so if we know the wind speed, the rotor diameter, its operating RPM, we can calculate actually directly the tip speed ratio. Okay, so the you can see it can put the values like the wind speed is v into multiplied by 60 due to because it's meter per second. So and the blade tip speed would be 2 pi r n divided by 60. Okay. N is the rpm, the rotation per minute. So per minute, from per minute to per second, we need to divide it by 60, and 2 pi r into its rpm. So 2 pi r is the perimeter of the circular motion. So if we need these values, the RPM, if we know the radius or this particular rotor diameter, we know the wind speed, we can directly calculate the tip speed ratio. Next question is the value of the wind shear component exponent alpha for urban area with tall building will be. So the correct answer would be zero point 0.4, and already told that it would be this is the alpha value. The wind shear exponent varies with the different locations. So for urban area with tall building, you can see the list is about zero point 0.4. So zero point 0.4 is the correct answer. And horizontal axis wind turbine with 25-meter rotor diameter produces 1 megawatt electricity at a wind speed of 50 km per hour, and the blade tip speed in meter per second for the TSR of 5.25. So in this problem, we have been given the TSR, the fixed speed ratio is 5.25. The wind speed is 50 km per hour. So the tip speed ratio is a ratio of blade tip speed divided by wind speed. So it's a very simple thing. The TSR is given, the wind speed is given. We have to just multiply. So, so the tip speed ratio is 5.25 multiplied by 50 is kilometer per hour. Just need to convert it to meter per second. So kilometer to meter is 1000 multiplied 15 to 1000 divided by 3600 from hour to second. So it's directly 72.91 meter per second. It's the correct answer. The tip speed. You have to very is very crucial. Have to be very careful whether it's tip speed ratio or the direct tip speed which is given. The next question is among the following which has the longest wavelength? Ultraviolet rays, radio waves, X-rays, gamma rays. The correct answer is the radio waves. In the solar spectrum, if you see, the radio waves having a very large wavelengths is in the centimeters and meters range, whereas the other ones having a wavelength of the gamma rays having a about an angstrom level, and the X-rays, ultraviolet rays, the nanometer range. The radio waves having the largest wavelength, lowest energy. Near which region the solar ray radiation incident will be maximum? The poles, the tropics, the equator, or all will receive the same amount? Correct answer is the equator, because I already told that obviously due to the solar insolation, the all areas doesn't get the same solar radiation. So at the equator, the solar radiation incident will be maximum. So what will be the R angle at a place 11 a.m. local time? 20 degrees, minus 45 degrees, 30 degrees, minus 15 degrees. So correct answer would be the minus 15 degrees. So we can see that by the help of the hour angle formula is about 15 into the local solar time minus 12 is the formula. We just put solar time equals to 11. So 11 minus 12 is minus 1. So 15 into minus 1 means minus 15. Minus 15 degrees is your correct answer. Which among the following solar concentrator type can attain the highest concentration ratio? Plane reflector, plane receiver, conical reflector, cylindrical receiver, paraboloidal reflector, spherical receiver, all of the same. Correct answer is the paraboloidal reflector, spherical receiver. Okay, so you can see the concentration ratio for the paraboloidal reflector spherical receiver is highest, is up to 10,000. Is less for plane reflector, plane receiver 1 to 4, conical reflector, cylindrical receiver 4 to 10, parabolic cylindrical reflector, cylindrical receiver 10 to 100. So paraboloidal reflector spherical receiver is the correct answer. So in this figure, you have to identify A and B. Okay, it's one type of solar concentrator. A is receiver, B is power barrel. A is receiver, B is heliocentric disk. A heliostat, B receiver, or none of this. The correct answer is A are the heliostats. Okay, and the B is the receiver. Okay, in the a kind of an example of power tower, one type of commercial concentrating collector. So the current produced in a photovoltaic cell, it depends on intensity of insolation, size of cell, both A and B or none of the above. So you can see the voltage and current in the IV shown in the IV curve of the PV cell. You can see that the uh, current in this particular PV cell, it depends on the intensity of insolation and size of cell. So why are wind turbines? This is the last question. Why are wind turbines mounted on towers? Uh, Wind speed increases with height. It is cheaper to install. It eases the maintenance, or none of this. So the correct answer is wind speed increases with height. Okay, as already told. So that is all from my side for today. If anyone have any questions, please let me know. Otherwise, we'll discuss. Okay, thank you.